Namaskar friends, we are discussing set theory in this class. So, in the last class we were discussing difference of set. Now, we will discuss some more laws and operations of set. As you see, two sets A and B. So, A minus B represented by the shaded region x such that x is an element of A, but x is not element of B, and similarly B and A. Now, what is symmetric difference of sets? This may be a new terminology to you, symmetric difference of two sets. Suppose A and B are two sets. So, we represent symmetric difference by a triangle, and this is represented by A minus B union B minus A. So, through Venn diagram, this is the universal set and A and B are two sets. So, A minus B will be this region and B minus A will be this shaded region. So, the union of both A minus P union B minus A is called the symmetric difference. The shaded region you can see will represent A minus B union B minus A, that is the symmetric difference between A and B. Let us take an example. Say A is equal to 2, 3, 4, 5, B is equal to 3, 5, 7, 9. So, what will be A minus B? A minus B will be equal to present in A, but not in B. So, 2 will be there, 3 will not be there because 3 is present in B, 4 will be there, 5 will not be there, 5 is present in B. So, 2 and 4 will be A minus B. What is B minus A? 3, 5, 7, 9. 3 is common. 5 also, 3 and 5 is common. So, 3 and 5 will not be there. 7 and 9. So, if we write symmetric difference between A and B, it will be equal to 2, 4, 7 and 9. Now, let us see some important laws. Idempotent laws. What is idempotent law? A union A will be equal to A, and A intersection A will also be equal to A. This is quite simple, quite understandable, nothing to explain, because A union A, the elements will be repeated, and you know in set theory we do not repeat elements. So, it will be equal to A, and intersection, all the elements of A will be another A. So, every element will be common. So, it will be equal to A. Then identity laws. Next one, what is identity laws? A union phi, phi is empty set. So, A union phi is equal to A, and A intersection U universal set will also be equal to A. It may seems to you strange, but these are important laws of mathematics. If you remember in arithmetic or algebra, phi is just similarly a plus 0 is equal to a. Union is similar to plus, not exactly equal, but similar, you can give simile. So, anything plus 0 is equal to the same thing, and again x multiplied by 1 will be equal to x. So, intersection is not equivalent to multiplication, but to understand the identity laws in set theory is like this. Now, another law is commutative law. You know, you might be familiar with this. So, A union B will be equal to B union A. Similarly, A intersection B will be equal to B intersection A. So, this commutative law holds good for set operations. This may not be true, say in algebra A minus B is not equal to B minus A. So, their commutative law does not hold, but here A union B is equal to B union A and A intersection B is equal to B intersection. We can verify it, it is not difficult. Say Venn diagram, this is A, this is B. So, A union B, this complete shaded region, and B union A will be same thing. Again A intersection B will be this region and B intersection A will also be this region. So, commutative law holds good for set operations, intersection and union. Now, associative law. What are these laws? It says that A union B union C will be equal to A union B union C. And similarly, A intersection B intersection C will be equal to A intersection B intersection C. So, these are associative laws, and this also holds good for set operations, union and intersection. We can take small examples and prove it, but you can do it, it is quite simple. So, I am leaving it here. Then distributive laws. It says A union B intersection C will be equal to A union B intersection A union C. So, you can see the operation union has been distributed within bracket on B and C. So, this holds good for set operations. Similarly, A intersection B union C is equal to A intersection B union A intersection C. So, let us take an example. Say A is equal to 1, 2, 3, 4, B is equal to 2, 4, 6, 8 and C is equal to 1, 3, 5, 7, 9. So, let us check the distributive laws. Say first one, what will be B intersection C? We are calculating B intersection C. So, 2, 4, 6, 8, 2, 4, 6, 8. So, nothing is common. So, B intersection C is 5. And what will be A union B intersection C equal to A, because B intersection C is 5. So, A union 5 will be A. So, it will be A. Now, what is this is equal to A union B intersection A union C. So, A union B is equal to 1, 2, 3, 4, 2, 4, 6, 8. So, 1, 2, 3, 4, 6, 8. Okay. And what is A union C? A union C is equal to 1, 2, 3, 4, 1, 2, 3, 4, 5, 7, 9, 5, 7, 9. So, what will be intersection of these two? Intersection of these two will be equal to A union B intersection of A union C will be equal to, common is these two. So, 1, 2, 3, 4 will be common, and then 6, 8 is not here, 5, 7, 9 is not here. So, it will be 1, 2, 3, 4. So, 1, 2, 3, 4, what is it? 1, 2, 3, 4, you can see this is A. This is equal to A. So, we have proved the distributive law here. See this one. Similarly, you can try this distributive law also, A intersection P union C. Try it yourself. Then we will come to next class and see some other rules also. Thank you, friends. Thank you very much for listening.